Okay, continuing in 3.1, let's talk about a little bit about vocabulary. So often you'll be asked to define y as a function of x. And we talked about in the last video how to identify whether or not y is a function of x. Now, to be familiar with some important vocabulary, in this case, x is known as the independent variable, and y as the dependent variable. Again, because y depends on the value of x. So, in the past, we've been looking at, for example, lines, something like y equals 2x minus 5. When we go to graph that line, we look at the xy points associated with that line. Well, now we're going to move more onto function notation. So y is f of x. So you will often see y and f of x used interchangeably. So now instead of looking at y equals 2x minus 5, we'll look at f of x is equal to 2x minus 5. So this is considered function notation, again, because I'm looking at y as a function of x. So this shows me, as I plug values in for x, what that corresponding y value will be. So now, just as we were looking at ordered pairs as x, y, we can also think of them as x, f of x. So for example, if I was giving you the ordered pair on a function 3, negative 5, what this is telling me is that f of 3 is equal to negative 5, or when x equals 3, y, or f of x, is equal to negative 5. So this is notation and vocabulary that you need to become familiar with. Okay, now the next two parts will be a little bit of review. We've already talked about this a little bit when we talk about substituting values in for x to evaluate an expression. Well, now we're pretty much going to do the same thing, but we're going to use function notation. So you'll be asked to find the value of a function. And then you'll be given different x values to substitute in. So, for example, let's say f of x is equal to 2x squared minus 5x, and then you might be asked to find f of 2. So what that means is, what is 2x squared minus 5x when x is 2? So I'll substitute 2 in for x in the f function. So 2 times 2 goes in for x squared minus 5 times 2. And then you just need to be cognizant of order of operations. So let's do that exponent first. So this will be 2 times 4 minus 5 times 2 is 10. Multiply before you subtract. So 8 minus 10 is equal to negative 2. So this told me that when x is 2, f of 2 is negative 2. So again, an associated ordered pair would be when x is 2, f of x is negative 2. Again, 2, and then f of 2, which is negative 2. Alright, let's keep that same f of x function, 2x squared minus 5x, but let's evaluate something else. What if it said, what is f of negative x? Sometimes you won't be asked to sub in a number, but an expression. So I'll replace x with negative x in our f of x function. So instead of x, I'll put negative x and then simplify. So a negative number squared is positive, so this is still 2x squared, but now negative 5 times negative x is plus 5x. So f of negative x is 2x squared plus 5. Now you may be asked to find something like negative f of x. So what does that mean? So negative f of x, since f of x, I lost my function up top, so I'm going to rewrite it. It's f of x is 2x squared minus 5x. So negative f of x just means negative f of x, which is x squared, 2x squared minus 5x. So the negative, keep the function in parentheses because that negative will now need to get distributed. So that's negative 2x squared, negative times negative is plus 5x. Okay. You may also be asked to perform operations on functions. And by operations I mean you may be asked to find a sum function or a product function. So by that I mean if you're being asked to find a sum, you could be asked to find f plus g or f plus g of x. And that just simply means f of x plus g of x. Likewise, you could be asked to find a difference function, or f minus g of x. And again, all that means is f of x minus g of x. And you'll be given an f of x and g of x function. Same thing with multiplying and dividing. The product can be thought of as f times g of x, meaning I would just multiply the two functions together, or f divided by g. So f divided by g of x, and again I would just divide the functions. So let's do a quick example. Okay, so let's say f of x is equal to 2x plus 1 and g of x is equal to x plus 5. And I'm being asked to find f plus g of x. So again, this just means f of x plus g of x. So I will just sub in the definitions of those functions. So this is just 2x plus 1 plus, I'm running out of room, so I'll put it underneath, x plus 5. So I'm adding, so this is just 2x plus 1 plus x plus 5, and then I'll collect like terms. 2x plus x is 3x, and 5 plus 1 is 6. So f plus g of x is 3x plus 6. Now you want to be careful when you're subtracting, because this would be, again, f of x minus g of x. So f of x is 2x plus 1. And again, I think it's a good idea to keep those parentheses there for this situation right here. Minus x plus 5. That minus will need to get distributed. So this is 2x plus 1 minus x minus 5. So 2x minus x is x. 1 and negative 5 is negative 4. So f minus g of x is x minus 4. Okay, as you can imagine, if I'm multiplying f times g of x, I would be multiplying 2x plus 1 times x minus 5, and you can guess that would need FOILed. if I am dividing, I'll have 2x plus 1 over x minus 5. Okay? Alright, last thing I want to talk about is algebraically identifying the domain of a function, and we have touched on this at different times in class. The two situations you need to be most aware of is when you're looking at a rational function. So by that I mean something like, let's say, 2 over x squared minus 1, because remember, I can't have a 0 in the denominator. Another situation you should be aware of that we've talked about are square roots. What if I had something like the square root of 2 minus 3x? I can't take the square root of a negative number. So these are two situations where my domain is going to be restricted. So if you're asked to identify the domain algebraically, then you need to think about what can't happen. So again, 2 over x squared minus 1, to identify which x values don't make sense, I would take the denominator and set it not equal to 0. So I would have x minus 1, x plus 1. So from this I can see x cannot be 1 and x cannot be negative 1. Now if I'm going to write that in interval notation, again, I still think it's a good idea to go to that number line first. So let's see, negative 1 and 1. It can't be negative 1 and it can't be positive 1, but it can be everything else. So that means I want to represent all of these values. And you will be asked to do this in interval notation. So again, this would be from negative infinity to negative 1, also in between 1 and negative 1, and then numbers larger than 1. And we would use those round parentheses because we don't want to include those values. Now, when I'm dealing with the square root, remember what's underneath the square root can't be negative. So 2 minus 3x must be greater than or equal to 0. I can take the square root of 0. So now solve the inequality. So we would have negative 3x is greater than or equal to negative 2. Divide both sides by negative 3. Remember, that means I have to change the direction of the inequality. So x is less than or equal to a positive 2/3. So interval notation, here's my 2/3. Less than would go this way. So I'm looking at negative infinity, comma, 2/3. I'm including, so square bracket around the 2/3 and parenthesis always around the negative infinity. Okay, so that concludes the notes for section 3.1. Open the next video and I want you to work on a small assignment before class tomorrow.